Hello guys. So in this session we are going to learn about OpenTelemetry. That means the introduction and details about OpenTelemetry. Okay. So let's start. So in this session, we are going to learn in this OpenTelemetry. So first of all, we are going to learn what is OpenTelemetry, then what is observability, then why OpenTelemetry, then main OpenTelemetry components, then the architecture of OpenTelemetry, then before OpenTelemetry, then existing tools, drawbacks, okay, and the history of the OpenTelemetry, then OpenTelemetry metrics, OpenTelemetry tracing, what makes OpenTelemetry different, then the problems, benefits, and use cases. Okay, so let's start. So first of all, what is OpenTelemetry? Okay, if you know what is OpenTelemetry, so OpenTelemetry is a unified open source project from the Cloud Native Computing Foundation, that is CNCF, right? And it is a purpose is to provide a single set of APIs, SDKs, and tools to instruments applications, meaning you can generate and collect telemetry data traces, metrics, and logs without being tied to a specific vendor proprietary agent. Okay. Then it provides the pipes for your observability data, separating data generation from data analysis. Okay, so that's the OpenTelemetry. In short, OpenTelemetry is an open source observability framework designed to standardize the generation, that collection, processing, and export of the OpenTelemetry data. Okay, then next is what is observability? Okay, so what is observability? So, observability is a measure of how well you can understand a system's internal state from its external outputs. Okay, and it's more than just monitoring, and it allows you to ask arbitrary questions about your system's behavior to pinpoint the root cause of issues and even for problems you didn't anticipate. Okay, then observability is built upon three pillars. Which pillars? Metrics, traces, and logs. Okay, so what is metrics? So metrics is a numerical data collected over time, like CPU utilization or request count to track system health. That's the metrics. Okay, then traces. The traces is the end-to-end journey of a single request as it passes through multiple services, crucial for understanding distributed system. And the last and third one is logs. So logs timestamp record of events within an application, providing detailed context of debugging. Okay, that's the three pillars of observability. Okay, then next is why we choose OpenTelemetry. Okay, here I mentioned some reasons, some causes to choose OpenTelemetry. So let's understand why OpenTelemetry. So OpenTelemetry was created to solve a significant problem in the industries. Okay, like vendor locking. Okay, then, before OpenTelemetry, an organization would choose an observability platform and then be forced to use the vendor's specific SDKs to instrument their code, and this made it difficult to switch vendors or use different tools. And OpenTelemetry provides a standard portable way to instrument your code once and allowing you to easily send your data to any backend, whether it's commercial product or an open source solution. Okay, so this standardization fosters a richer ecosystem and promotes innovations. Okay, so that's the reason we choose OpenTelemetry. Then here I mentioned some main components about OpenTelemetry, that APIs and SDKs, OpenTelemetry collector, then here receivers, processors, and exporters. Okay. So first of all, let's understand the architecture first. Okay. So in this architecture, as you can see, first of all here, Opentelemetry APIs and SDKs, then traces, application, and the receivers, exporter, processors, and so on, Opentelemetry collectors and details. Okay. So let's understand in detail. So first of all, as you can see here, Opentelemetry APIs and SDKs. Okay. Okay. So here you can see, first of all, the API are the standard interface that let you instrument your code to generate telemetry data, right, without vendor lock-in. And the SDK are in the implementations of three APIs for specific programming language. Okay, together. Okay, and they allow you to collect data from your applications. Okay, so you can see example traces, meters, loggers, auto instrumentations, and so on the details. Right, okay. The next one is Opentelemetry Collector. As you can see, Opentelemetry Collector here. So, Opentelemetry Collector is a powerful vendor agnostic proxy that receives, process, and exports telemetry data. And it's an essential part of the architecture that offloads data handling from your applications, and it contains three main parts, which receivers, processors, and exporters. Okay. So, what is the working of receiver? Receivers, they are entry point for data, accepting it from various sources and formats. Then processors, they transform the data, allowing to filter, enrich, or sample it before exporting. And the exporters, they format and send the processed data to your chosen backend. Okay, that's the working of it. Then next one is that's exporters. Okay, here. Okay. So this exporter is these exporters are component responsible for sending the collected and processed data to an observability backend. And they can be part of the application's SDKs or within the OpenTelemetry collector. And this is the final step in the pipeline collecting to your instrument code to the tools you can use and analysis. Okay, so that's the architecture of our OpenTelemetry. Okay, so you can see here architecture. Then, okay, okay. The next one is before OpenTelemetry. Okay, so in the past, the world of observability was fragmented. Teams often used a patchwork of different monitoring tools. For example, one tool for metrics, another for logs, and the third for distributed tracing. So this created operational complexity and high total cost of ownership. So each tool required its own proprietary agent, and the lack of common data format means data collection was manual, often painful or process, or you can see also lengthy, right? Because each for that we need different tools, like one for metrics, another for logs, and third for distributed. Okay, so before telemetry in past, like that. The next one is existing tools and drawbacks. Okay. So the traditional approach to observability came with several significant drawbacks: vendor lock-in, complexity, high cost, lack of interoperability. So first of all is vendor lock-in. So in the property nature of SDK meant that if you decide to switch observability providers, you had to re-instrument your entire application, a time-consuming and costly process. The next one is complexity. Running multiple agents on a single server to collect different types of telemetry data was inefficient and resource intensive. High cost property agent and platform often came with heavily licensing fees. And the last one is lack of interoperability. So different tools uses different data formats, making it nearly impossible to correlate metrics, traces, logs, and unified way. That's the existing tools drawbacks. The next one is history of OpenTelemetry. So, if you don't know the history of OpenTelemetry, so the OpenTelemetry was born from the unification of two popular open source projects, OpenTracing and OpenCensus. So, OpenTracing focus exclusively on distributed tracing, while OpenCensus provide libraries for both tracing and metrics. Okay, so recognizing the need for single comprehensive standard, the project merged in 2019 under the CNCF. They created the robust all-one solution we have today and combining the state of both projects into a single cohesive framework that is OpenTelemetry. So the next is OpenTelemetry metrics. So OpenTelemetry provides a rich set of metrics types to measure different aspects of your applications like counters, gauges, histograms. So counters, typically increase value useful for counting things like the total number of requests served, then gauges, a value that can go up or down at any time, perfect for measuring like things like current CPU usage or the number of active users. Then histograms used to measure the distribution of a set of values such as request latency, allowing you to see not just the average but the full range of performance. Okay, and this matrix provides high level aggregate insights into system health. So that's the OpenTelemetry metrics. Then next one is OpenTelemetry tracing. So, tracing is a core component of OpenTelemetry, providing a way to visualize the end-to-end flow of a request through a distributed system. And a trace is a collection of spans where each span represents a single name operation, example, a database query of an API call. And spans are linked together to show the causal relationship between operations, allowing developers to see where time is spent, identify bottlenecks, and pinpoint exactly which service is causing an error. That's the OpenTelemetry tracing. The next one is what makes OpenTelemetry different. So, what makes OpenTelemetry different? So, let's understand. So, OpenTelemetry stand out because it is a standard, not a product. So it focuses on the collection and export of data, leaving the analysis and visualization to specialized backends. And this separation of concern is its greatest strength. And it is a unified solution for all three pillars of observability. Okay, so we have learned the pillars of observability, right? And its vendor agnostic nature provides an unpredicted level of flexibility. And the project is backed by the thriving open source community and major teach companies, ensuring its continued development and relevance. So that's the things to make OpenTelemetry different. Next one is the problems. So what's the problems in OpenTelemetry? So despite its advantages, OpenTelemetry is still evolving and some features are experimental and configuration can be complex for beginners. And if not managed properly, instrumentation may add performance overhead, creating new challenges in the large scale deployments. There's some problems in OpenTelemetry. Then, okay, that's important, right? The benefits of OpenTelemetry. So, what's the benefit? So, the benefits adopting OpenTelemetry are significant and far-reaching. First is faster troubleshooting, improve performance, increase agility, and cost saving. Faster troubleshooting. So it's with a clear view of distributed traces, teams can quickly identify the root cause of performance issues or errors, reducing means time to resolution. MTTR. Okay. Then improve performance. By using metric and traces, team can gain deep insight into system behavior, identify bottlenecks, and optimize their applications. Then increase agility. The freedom to switch backend allow organization to adapt quickly to new tools and technologies without a major refactoring efforts. And last, cost saving. By choosing open source backend or negotiating better deals with vendors, organization can reduce their observability cost. So that's the benefits of OpenTelemetry. Then use cases. OpenTelemetry is a particularly well suited for modern dynamic environment. So microservices architecture, cloud native applications, serverless computing, and application performance monitoring, that is APM. Okay. So first is microservices architecture. It is essentially for monitoring the complex web of interactions between services. Then cloud native applications designed to provide visibility into applications running in containers and orchestrated platforms like Kubernetes. Then serverless computing, it provides the necessary insight into functions as a service, that is FAAS, functions as a service, and other inferior workloads. Then application performance monitoring, APM. It forms the foundation for building or using a robust APM solution. That's the use cases of OpenTelemetry. That's it. Thank you. So, so in this session, we have learned what is OpenTelemetry, what is observability, why OpenTelemetry we use, main OpenTelemetry components, architecture of OpenTelemetry, before OpenTelemetry, existing tools, drawbacks, history of OpenTelemetry, OpenTelemetry matrix, OpenTelemetry tracing, what makes OpenTelemetry different, the problems of OpenTelemetry, benefits of OpenTelemetry, and the use cases of OpenTelemetry that we have learned in this session. So, thank you for watching, and I hope you understand.